Hey, I'm Dave. Welcome to my shop. This is my PDP 1173 that I just picked up out of Canada, and as you can see, I let the magic smoke out of it. It was actually much worse than this, but it took me a moment to unplug the machine and get my camera out and start filming, so this is really just the hazy aftermath. What I did next reminds me of the old joke. A programmer, an engineer, and a mechanic are driving down a mountain pass when the brakes fail on the car. They barely manage to survive careening down the roadway, but eventually get the car stopped at the bottom of the hill. The mechanic says, I need to take the brakes apart and figure out what's wrong with them. But the engineer says, actually, I think they're just undersized for this car and they really should be redesigned. At which point the programmer says, well, why don't we just push it back up the hill and see if it happens again? And so that's what I did next. I plugged the power cord back in and powered the machine up. And it dutifully spun right up and worked perfectly. But how did I know that it would be quote-unquote safe to plug it back in, and why would everything continue to work properly after such a massive smoke show? That's because I was almost morally certain, but still uncertain enough to be curious, I guess, that it was a Rifa capacitor, one of those little components that have earned a notorious reputation among retro tech enthusiasts for going out with a bang. If you've ever cracked open an old power supply, or restored a vintage computer, or nursed a classic arcade machine back to life, chances are you've encountered these ticking time bombs, or at least smelled the aftermath. We're going to look at what Rifa capacitors are, what they do, why they're stuffed into power supplies, why they fail so spectacularly over time, and what happens when they blow, and whether you should rip them out of your circuits or just cross your fingers and hope for the best. First off, what exactly is a Rifa capacitor? Well, Rifa isn't just a catchy name. It's the brand behind these infamous components, a Swedish company that started making these capacitors back in the 1940s. They were acquired by Comet in the 90s, but the capacitors we're talking about today are the old originals, the ones that rolled out of the factory decades ago and found their way into equipment from the 60s, 70s, and 80s. Specifically, we're zeroing in on their metallized paper capacitors, often labeled with cryptic codes like PME271 or X2. These aren't your run-of-the-mill ceramic or electrolytic capacitors. They're a special breed built with a thin layer of metal vapor deposited onto a paper dielectric, all wrapped in a plastic casing, usually a translucent yellow or amber shell that's become the stuff of nightmares for vintage tech collectors. So what do these things do? Well, in the simplest terms, capacitors store and release electrical energy on demand, acting like tiny buckets that can smooth out voltage spikes, filter noise, or block certain frequencies in a circuit. Rifa capacitors, particularly the X2 class ones that we're focusing on, were designed for a very specific job, suppressing electromagnetic interference, or EMI. Think of EMI as the unwanted static that your electronics can spit out or pick up, like a radio station bleeding into your TV signal, if you still had an analog TV. These capacitors sit across the AC power lines, usually right at the input of the power supply, shunting high-frequency noise to ground and keeping it from wreaking havoc on the rest of the circuit, or escaping to annoy your neighbor's ham radio. They're rated for pretty high voltage, typically 250 or 275 volts AC, and they're built to handle the rough and tumble world of mains electricity. That's why you'll find them in everything from old IBM PCs to Commodore 64 power bricks, vintage hi-fi gear, and even industrial equipment. They're the unsung heroes of clean power, or at least they were supposed to be. Now let's talk about why they're in power supplies in the first place. Back in the day, as electronics became more common in homes and offices, governments started cracking down on electromagnetic interference. Regulations like those from the FCC in the US or the VDE in Europe demanded that manufacturers keep their devices from turning into little radio jammers. If you ever operated a TRS-80 Model 1 in a home environment, you know that you couldn't use an analog TV within about 20 feet of the thing when it was turned on. And I'm not exactly sure what the cause was for the TRS-80, but power supplies, being the gateway between your wall socket and your precious circuits, were prime candidates for EMI control. Enter the X2 class capacitor, affordable, effective, and compact. Rifa's metallized paper design was a popular choice because it offered decent performance for the price and it could self-heal to a degree. If a tiny short occurred in the dielectric, the metal layer would vaporize around the fault, isolating it and letting the capacitor keep on working. On paper, pun intended, it was a brilliant solution. Manufacturers loved them and Rifa cranked them out by the millions. But here's where the story takes a dark turn. These capacitors don't age with grace. They degrade like a forgotten love letter in a damp attic, a once crisp promise fading into brittle, illegible whisper. The problem lies in that metallized paper core and the plastic casing around it. Over time, decades in the case of vintage gear, environmental factors like heat, humidity, and even the constant stress of being exposed to mains voltage breaks them down. The paper dielectric, being organic, is particularly vulnerable. Moisture seeps in through microscopic cracks in the epoxy or plastic shell, especially if the seal wasn't perfect to begin with. Once inside, it degrades the paper, and that reduces its ability to insulate the middle layers. Meanwhile, the plastic casing itself can become brittle, cracking further and letting even more moisture in. It's a vicious cycle. Add in the fact that these capacitors are often sitting right next to heat-generating components in a power supply, and you've got a recipe for disaster. So why do they fail? Well, it's not just that they stop working, they fail catastrophically. As the dielectric weakens, the capacitor's ability to handle voltage drops. Eventually, it just can't withstand the 120 or 240 volts it's rated for. When that happens, the metal layers short out, and instead of a controlled, self-healing zap, you get a full-on runaway breakdown. Current surges through the fault, generating heat, lots of it. That heat vaporizes whatever's left of the paper and epoxy, turning it into a gas. Because all this is mostly trapped in a sealed plastic case, the pressure builds until, boom, and the capacitor explodes. Well, explodes might be a bit dramatic, but it's not far off. The casing ruptures, often with a loud bang or a pop, and out comes a plume of acrid, sort of fishy-smelling smoke. Sometimes there's even a flash of light or a shower of sparks if the short arcs across nearby components. It's not a subtle failure. It's the kind of thing that makes you jump out of your chair if you're working on a live circuit. Let me paint you a picture of what actually happens when a Rifa cap blows. I was sitting in the shop here with Glenn from the Shop Talk podcast, check it out, the link in the video description, and I had just taken delivery of an old Commodore Super Pet SP9000. I had disconnected the monitor and the motherboard and then plugged it in to check some voltages before risking the rest of the components. Everything checked out fine, so I turned it off, but I didn't unplug it. And about 5 minutes later, there was a loud kapow and a surge of smoke came out of the Super Pet. That's because the way that the Super Pet power supply is designed, the Rifa caps are exposed to line voltage whenever the machine is plugged in, whether it's turned on or not. If you're lucky, you might see a flicker of orange flame or a spray of molten epoxy splatter across the board. Now, the power supply might even keep on running for a second or two, but sometimes the short trips a fuse or fries something downstream, like a rectifier or a regulator, leaving you with a dead unit and a lingering stench that'll haunt your workbench for hours. I've seen it happen firsthand, as you saw, and trust me, it's not the kind of excitement you want in your day. Fortunately, in the case of the Super Pet, the Rifa cap is contained in its own little metal dungeon. Now, this isn't just a random fluke. It's so common that Rifa capacitors have become infamous to the retrotech community. Search any forum like Vogon's or Reddit's Vintage Computing, and you'll find horror stories. It's not so much a question of if they'll fail, but when. And if you're dealing with gear that's been sitting in a damp basement or hot attic, that when gets a lot closer and more certain. So what's the fallout when one of these goes bang? Well, beyond the smoke and the smell, the damage depends on the circuit. In a well-designed power supply, a blown Rifa cap might just trip a fuse or breaker, leaving the rest of the system intact. But in cheaper designs, or if the fuse is slow to react, the short can dump excess current into other components, frying diodes, resistors, or even transformers. I've heard horror stories of boards where Rifa cap failure took out half the input stage, turning a simple repair into a full rebuild. And then there's a mess. The exploded cap often leaves behind a gooey, charred residue that's a pain to clean off. If you're lucky, it's just cosmetic damage. If you're not, you're sourcing replacement parts or a whole new unit. And so you've got to do something, but that brings us to the big question. Should you actually replace these little things, or can you just yank them out and call it a day? Well, to answer that, let's step back and think about their role. As noted, the caps are there for EMI suppression, keeping noise off the power line and ensuring that the device meets regulatory standards. In theory, if you remove one, the circuit will still work fine. The power supply doesn't need it to function. It's not filtering the DC output or stabilizing voltages for the downstream electronics. It's just there to keep the AC side quiet. So in a pinch, or if you're restoring something for personal use and don't care about EMI, you could leave it out. I've seen plenty of hobbyists do just that, especially on gear that's not leaving their basement. No cap, no boom, problem solved. But here's the catch. Fine isn't the same as optimal. Without that capacitor, your device might generate more electrical noise, potentially interfering with other equipment, like vintage FM radio or your neighbor's Wi-Fi or who knows what. It might even pick up noise from the power line, causing glitches or hum in sensitive circuits. And if you're selling a restored unit or using it in a professional setting, skipping the cap could technically violate FCC regulations, though, let's be honest, nobody's busting down your door over an 83 VIC-20. Still, for purists or anyone aiming for a factory-fresh restoration, replacing them is the way to go. If you do replace it, don't just slap in another old vintage Rifa that you found in your parts bin or something, because those are just as likely to blow. Modern X2 class capacitors are a much better bet. Look for metallized polypropylene film capacitors from reputable brands like Vishay, Wima, or it's probably Vima, or Panasonic. They're drop-in replacements, same size, same ratings, but they use a plastic dielectric instead of paper, so they're far less prone to moisture damage and catastrophic failure. They're cheap too, a couple of bucks each, and they'll outlast the gear they're in. I even keep a stash of various X2 caps in the shop just for this reason. Swap out the old Rifa, fire up the unit, and you've got peace of mind without sacrificing authenticity. Here's a pro tip I sometimes follow. If you're working on vintage gear you care about, check them before you ever plug it in. Look for cracks in the case, bulging, or a cloudy appearance. Those are red flags that it's about to pop. I've gotten into the habit of preemptively replacing them and generally anything I really care about that's older than about 20 years. It can be a 10-minute job with a soldering iron, especially if you've got a desoldering tool, and it beats scrubbing burnt epoxy off your workbench. Plus, it's oddly satisfying to defuse these little bombs before they can ruin your day. For the retro community, Rifa's notoriety is almost a badge of honor. They're kind of a shared experience, a rite of passage for anyone brave enough to resurrect a dusty old machine. And their explosive failures? Well, they make for great stories. It's the kind of chaos that keeps you hooked on this hobby. Now, if you've enjoyed this little deep dive into the world of Rifa caps, equal parts tech history and cautionary tale, I'd be honored if you'd hit that subscribe button. I'm mostly in this for the subs and likes, so please be sure to leave me one of each before you go today. And if you're already subscribed, thank you. I'd love to hear from you in the comments. Tell me your own Rifa horror story or what vintage gear you're planning on wrestling with next. And we answer some of the very best viewer questions almost live every Friday on Shop Talk. We run it on the Dave's Attic channel, so check that out at the link in the video description, and I think you'll enjoy it. Thanks for joining me out here in the shop today. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage.
Do it, Glenn! Do it! Do it!